Today we are starting 2.1, which is titled, What is a Function? So by the end of today, we're going to be able to find domains of functions, which technically we've already been working on. And we're also going to be able to evaluate functions, given values, and expressions. So you've already done values before. Expressions is something you might need some more practice on. And the first thing we're going to do is talk about piecewise defined functions. Okay, so piecewise, the main word in that is piece. It really is different pieces of a function. And those different pieces are defined by different formulas. Or expressions on different parts of its domain. Okay, so you have the different formulas on different parts of its domain. So a lot of times, and you can see in the one below, you'll have these inequalities. X is less than or equal to 3, x is greater than 3. Those are two different parts of its domain. Remember that the domain is going to be all the possible input values. Or a lot of times we'll say all the possible x values. So that's what we're going to be working on still today. So example 1, it says evaluate the piecewise function, or the piecewise defined function at the indicated values. Go ahead and look over that real quick. Okay, and then Lucas, tell me, what am I supposed to be doing for example 1? What am I trying to find? Well, use the directions to help you.
Evaluate the piecewise defined function.
Okay, and what are those indicated values?
1, 3, 5.
Good, okay, so you're evaluating the function for f of 1, f of 3, and f of 5, and you said 1, 3, and 5. So if we have f of 1, Lucas, do you know what we'd have to do for that?
You use the first.
Yep, and you just are going to replace what with what?
X.
Okay, yeah, so if it's f of 1, do you guys remember doing that in Algebra 2? Okay, so if you're finding f of 1, you're just replacing the x with 1. Because this is a piecewise, we have to determine which equation we're going to use, and that's based on this inequality. So is 1 less than or equal to 3? Yes, so then I have to use the first one. So if I'm finding f of 1, I'm going to use 3 minus x, which is going to be 3 minus 1, which is just 2. So my f of 1 is going to be 2.
That's the answer.
Yeah.
Oh,
Okay, so now we found f of 1, now we have to find f of 3. Okay, so Michaela, help me determine which equation I want to use. So do I want to use 3 minus x or x squared, and can you tell me why?
3 minus x because it's greater than or equal to.
Good, okay, so 3 is greater than or equal to 3, so I have to use this 3 minus x again. So for f of 3, it's going to be 3 minus 3, so f of 3 is just equal to what? 0. Okay, Charlie, what about f of 5?
You use the second
Why?
because 5 is bigger than 3.
Good, okay, so 5 is not less than or equal to 3, so I am not going to use the first equation. 5 is greater than 3, so I will do 5 squared, which will be 25. So f of 5 is going to equal 25. Okay, questions for me about that one? That is something that you did in Algebra 2. If you were using your textbook, it was Chapter 6, Section 3, so 6.3. And then I'm asking you, what if there was no x in the expression? and you just had a constant, how would you evaluate? So what I mean by that is if you had like this, so if you had 10, if x was less than or equal to 3, and 2, if x was greater than 3. What's that? You can think of it like a graph, right? Because 10 and 2, those are both what kind of lines? What are they going to look like when I graph them? Straight which way? Horizontal, right? Because this is like y equals. So this would be y equals 10. Really, it should be a 3. We're going to graph them a different day, but I am going to do this correctly. Okay, so this is going to be a horizontal line, right? They're both going to be horizontal lines. Well, if I plugged in a value that was less than or equal to 3 and it was 10, what would my output be? My output would be 10, right? Is there anywhere I can plug in x? No. If you have the line of 10, no matter where you are, you're going to hit 10. No matter where you are on this interval, you're going to hit 2. Okay, so it doesn't matter which value you have, your solution is always going to be the constant. Okay, so your solution will always be the constant if there is no x terms, really are, if there are no x terms in your expression. Okay, so your solution is always going to be the constant, no matter what it is, if there are no x terms in your expression. Okay, so your solution will always be the constant if there are no x terms in your expression. All right, let's go to the next one. So I'm going to give you a second to read your directions. All right, and then Caleb, what are we trying to do for part A?
Evaluate for f of a plus h.
Yeah, so we're trying to evaluate for f of a plus h. Okay, so let's talk about what that means. If that was just f of 1, what would I do with the 1? Plug it in for x. So this is the same thing, except now you are going to substitute a plus h for x. So now, instead of just plugging in a number, I'm plugging in an entire expression. So any place there's an x, you're going to replace it with what? A plus h. So do you guys think you can do that? Any place there's an x, you're going to rewrite it with a plus h? Can you give that a try? Yes.
Do you multiply it out?
Yeah.
Yeah.
Yep, if you have plugged it in, go ahead and you can simplify. Okay, so I have f of a plus h, so I have 3x squared. So instead of x, I'm going to have a plus h squared plus 4 times a plus h minus 1. How do we do with just the substitution? Good, okay, so the next thing we have to remember, a plus h squared is not a squared plus h squared. What do you have to do with this? You have to FOIL it. Okay, so I like to write it out at this part so you guys remember that, hey, I have to FOIL. I'm going to distribute the 4. So this will be 3. When I FOIL, I have a squared plus 2ah plus h squared plus 4a plus 4h minus 1. And now I can distribute my 3, so I have 3a squared plus 6ah plus 3h squared plus 4a plus 4h minus 1. I do not have any like terms, so that whole thing is my solution. Okay, I don't have any like terms, so I'm just going to keep it just like that. Questions for me on that one? Okay, let's try the next one. So for the next one, I'm going to evaluate f of a plus h minus f of a over h. Okay, so that seems kind of overwhelming, right? Let's just break it down. F of a plus h just means I'm going to plug in what? A plus h for x. So can we do that step first? So this is 2a plus h squared plus 4 times a plus h minus 1. See how that's all I've done so far? All I've done so far is just the f of a plus h. Is that okay? Alright, so now I have the minus f of a. Well, if I have f of a, first I have a minus, so I'm going to make my parentheses so I don't forget. I'm going to have to distribute. And if I have f of a, I'm just going to have f of x, but instead of x, what am I going to have? I'm going to have a. So I'm going to have 2a squared plus 4a minus 1. And all of that is over what? It's over h. See how it's not f of h? It's just h. So I don't have to plug h in anywhere. It's just going to stay as my h. And then I have the fun task of simplifying everything. Okay, so similarly like we did on the last one, we're going to go ahead and simplify. And didn't we just do the a plus h squared, or to the power 2 on the last one? So this would be 2, and I'm just going to have a squared plus 2ah plus h squared. I'm going to distribute the 4. And it's actually better if you guys do this on your own paper and then just look up to check instead of just copying down what I'm doing. And then don't forget to distribute. So I have negative 2a squared minus 4a plus 1, and everything's over h. And then, so I don't have to write everything out again. Since this is just distributing by 2, I might write that just above. So I have 2a squared plus 4ah plus 2h squared. And now I'm going to find like terms. So I have 2a squared. Here I have minus 2a squared. Okay, so then those two are going to cancel out. And then I have 4ah. Do I have any other ah's? Nope, so I'm going to have 4ah be my first thing I'm writing on my next step. I have 2h squared. Do I have any other h squareds? Nope, so I'm going to do plus 2h squared. So I did that one, I did that one. I have 4a. Do I have another 4a? Yep, I have negative 4a, so those will cancel. I have 4h. Do I have another h term? No. and then I have -1, and I have +1. So then that's all I should have on top is 4AH plus 2H squared plus 4H over H. Is there anything you noticed that I can do? Okay, yeah, you can factor out the GCF. And you can decide, you can factor out an H. Can you factor out anything else? Yeah, the 2. So if you have 2H, it's like you're dividing. So 4 divided by 2 is 2. AH divided by H is just A. 2H, if you take 2 divided by 2, you have 1. H squared divided by H is H. 2H, or you have 2H, so 4 divided by 2 is 2. H divided by H is 1. And then you have H on the bottom.
So if you got your H, like, you're allowed to, like, take it out on the top, you don't have to do anything to the bottom?
Nope.
Like,
So,
like, I feel like,
because you're just factoring the top. Right? So you're just factoring the top, you're taking out the GCF. So now, this is 2H multiplied by this quantity. So can my H's divide out? Yep. I'm just, in the next step is where I'm going to put that they cancel. You guys can put it in that step. It's just easier for people to see when I have it written out like this, so I can cross it out at this step. And then you can write your answer as either 2 times 2A plus H plus 2, or you could also distribute it again, and you could have 4A plus 2H plus 4. Either one of those I would count correct. It does not say to leave this in factored form. So either one of those are fine. Okay, questions for me? Ready for the next one? Okay, so if f of x is x plus 4, we have to evaluate f of x plus 2, and then f of x plus f of negative 2. So let's do the f of x plus 2. So if I have x plus 4, instead of x, I have to substitute x plus 2. So this is really going to be x plus 2 plus 4.
It's on the screen.
Thanks. Okay, so if I have x plus 2 plus 4, I can add 2 and 4 together, and that would leave me with x plus 6. I only put the parentheses in there to show you that instead of x, I have x plus 2. Okay, so it's a substitution. It's a replacement. For the next one, for f of x plus f of negative 2, how many substitutions am I going to have to do? 1 or 2?
2 or 1 technically.
Well, f of x, I'm going to have to replace x with x, but it's the same thing, right? Okay, and then f of negative 2, I'm going to have to replace x with negative 2. Okay, so I'm going to do 2 different things. So f of x is x plus 4. And this is plus f of negative 2, which would be negative 2 plus 4. Okay, so this is my f of x plus, this is my f of negative 2. I'm sorry, because you can't really see that at all. Okay, and then you can go ahead and simplify. So this is x plus 4 plus 2, which is going to be x plus 6. So f of x plus f of negative 2 just happens to be x plus 6, just like the one we just did. Okay, questions for me on that one? All right, let's move on on to the domain. So we have to find the domain of the function. And then we are going to write our solutions in interval notation. So remember, with the domain, there were a couple things that we had to watch out for. And I'm going to write them right on the side here. So with the domain, Sam, what's one thing we had to watch out for with the domain?
No zeros on the denominator.
Okay, so if there's a fraction, then the denominator cannot be 0. Okay, Blake, what's something else we had to watch out for?
Radical.
Yep. And do you remember what we'd have to set up for the radicals? Because what can't we have? Blake, do you remember? What can't we have under the radical? Can't have a negative, right? Okay, so we can't have any negatives underneath. So we would set the radicand greater than or equal to 0. And then in rare cases where we have both, then you set the radicand on the denominator. Greater than 0. You guys remember that from 1.4? We had that little chart. Can equal 0, greater than or equal to 0, or greater than 0. Okay, so that's exactly what we're going to do here. It's just we're going to mix a few things together. Okay, so the first one. Do I have a fraction or a radical? Or both? I have a fraction. Okay, so if it's a fraction, then Ryan, what do I do? Okay, so what can equal 0?
X.
X squared plus X.
Oh, X.
Okay, so what can equal 0?
X squared this way.
Yeah, the denominator, right? The denominator can equal 0, so it won't just be x, it'll be x squared plus x, right? And that cannot equal 0. Is this a linear equation or a nonlinear equation? How do you know? Okay, so it has the x to the power 2, right? Remember we called that the degree, so if the degree is bigger than 1. Okay, so if it's not linear, I'm not just going to add things over. What do I have to do? I have to factor, right? Okay, so I'm going to factor. And I can factor out the x, because that's my GCF. So if I factor out the x squared divided by x is x divided by itself is 1. And then I know that either x can't be 0, or x plus 1 can't be 0. And if I solve that, I'll know that x cannot be negative 1 or x can't be 0. That's the domain, but now I have to write that as an interval. So if you have trouble writing that as an interval, do you guys remember what I suggested? Yep, to graph it on your number line. Okay, so if you graph it on the number line, you have negative 1 and you have 0. And then do you have soft brackets or hard brackets for this? Soft, because it cannot include those values. So then you're looking at this interval first, right? From negative 1 below, you're from negative infinity to negative 1. The middle interval is negative 1 to 0, and then your last interval is 0 to infinity. So your solution is going to be all of those intervals, but they're connected with a union. Okay, so see how that combines a few different things that we've used before? Okay, let's try part B. Okay, so the first thing you have to solve, fraction or radical, what do we have? Okay, and we have a radical. So each of you tell me what equation I can set up from that?
The rad, 16 minus x squared is greater than or equal to 0.
Perfect. Okay, so whatever's underneath the radical, it cannot be negative. So I'm going to set that greater than or equal to 0. Now I know a lot of you want to add over the x squared and then take the square root, but then things get kind of messy. So we're not going to do that. Remember, ask yourself if it's linear or nonlinear. Is this linear or nonlinear? Okay, so this is a nonlinear inequality. Do you guys remember what we have to do with nonlinear inequalities? Yep. And what else? Or do you guys remember what section we did these in? The nonlinear inequalities? You didn't have the radical. You would have just been given this. We did it in 1.7. You guys just took your test on that part, right? If it is nonlinear, then the first step was to move everything to one side, and then the second step was to do what? Factor. Okay, so that's what we're going to do, is we're going to factor. And this is a special pattern. This is what pattern? Difference of squares, right? So square root of 16 is 4. Square root of x squared is x. So it's 4 plus x and 4 minus x. Okay, so then your two values, you want to find out the values that would make those 0. Okay, so for this one, what would x equal? That would make 4 plus x 0. Negative 4, and for the second one, 4. So remember, we're going to put those on our number line. And what else do we have to do? Are these hard brackets or soft brackets? Good, okay, so for this, you're always going to have hard brackets when you're doing this one because it's a radical. And if it's a radical, you're going to have greater than or equal to 0. The only time you wouldn't have a hard bracket is when?
Infinities.
Yeah, good, if the radical's in the bottom. And then, yeah, the infinities will always be soft. Good, so if the radical's on the bottom, that's the only time you'd have the soft brackets. Do you remember what to do from here? Uh-huh.
Like put interval, use union to get them.
Nope. Not for the inequality. You have to do what?
You have to find the product to see which one would be.
Which one would be positive and negative? Remember, you have to figure out which intervals are positive and negative by finding the product of them. And we can set up our little chart for that, right? Remember how I showed you you could just change this into your chart here? Okay, so then your two factors are 4 plus x. Sorry. No, that's hard to see. 4 plus x and 4 minus x. And I like to make my little chart right from here. So make sure that you're picking a correct value. So something in between negative infinity and negative 4. So I could choose negative 5. 4 plus negative 5 is negative 1. So that's a negative. 4 minus negative 5 is what? Positive, right? So minus and negative will be plus, plus. Okay, so you are going to have a positive there, and that would be negative. For this one, I'll choose 0. So this would be positive, this would be positive, this would be positive. And I'll choose 5, so that would be positive 9 and negative 1. Which interval am I looking for, the positive or the negative? Am I always going to be looking for the positive for this? So before in 1.7 it would switch, right? Sometimes it'd be negative, sometimes it would be positive. It all depended on what? The sign. Why is this always going to be positive? Yeah.
Because you always want it greater than or
Yeah, when you're finding the domain, you always have to set the radical so that it's greater than or equal to 0, right? So you're always going to be looking for the positive when you're finding the domain. Okay, so you're always be looking for the positive now. So then your solution is just going to be what? Negative 4 to 4. And that's already in your interval notation. Okay, and then for the last one, we have a radical on the bottom. So Mitchell, what's my equation going to be?
X plus 2.
Mm-hmm.
Or, yeah, has to be greater than 0.
Yep. And then is this linear or non-linear? Linear, which is really nice because then all I have to do is move that over, and then I just have to write that as an interval, which I know a lot of you can probably do without doing the number line, but if you wanted to, you could. Right? So I'd have negative 2, open circle. Is it going to the left or the right? The right. Okay, so then your interval, would it be hard bracket or soft bracket? Soft bracket. And it would start at and go to infinity. Sorry, both of those are soft. Now I have to make both of them soon. Okay. All right, great. All right, then the last thing we're going to do today is a story problem. So the cost C in dollars of producing X yards of a certain fabric is given by the equation. So yeah, we definitely have to know what the equation is. That'll be important. But it's also important to know what our variables are representing. Okay, so we know that the cost, C is in dollars, and that's of producing X yards of a certain fabric. The first thing it says is to find C of 10 and C of 100, which we're going to do without a calculator. If you have a value that's harder to calculate without a calculator, it's fine if you use one. If you had 2.5, fine, do it. But with this, you just have 10 and 100, so we're going to see how simple that is using our mental math skills. So first we'll do C of 10. So all I'm doing is replacing X with 10. So I have 1,500 plus 3 times 10 plus 0.02 times 10 squared plus 0.0001 10 to the third. Okay, so 3 times 10 is 30. 10 squared is 100. So if I'm multiplying by 100, what's the only thing I have to do? Yeah, I just have to move the decimal over 2 places. So if I do 0.02 times 100, it's just going to be 2. And do you guys know 10 cubed? 1,000, right? So 10 times 10 is 100, 100 times 10 will be 1,000. So I'm going to have 0.0001 times 1,000. So then how many places do I move the decimal? 3. 1, 2, 3, which is going to give me 0.1. Okay, so if I add all those up, I have 1,500 plus 30 plus 2 plus 0.1. So C of 10 is going to be 1,532.1, but this is cost, so I'm going to change it to 10 cents. Okay, and then I want you to see if you can do the C of 100, and then we'll check ours together. you guys doing with the 100 times 100? So 10 times 10 is 100, right? How many zeros do you have at the end? When you do 10 times 10 and you have 100, you have how many zeros? You have 2. So if I do 100 times 100, I'm probably going to have how many zeros? 4. So that would be 10,000, right? Okay, and then when we did to the cubed, it was 1,000. We had 3 zeros. So now if we do 100, we're going to have how many zeros? Now I have 2 zeros, so now I'm going to have,
We can't see it.
I know. I don't want you to see it. So when you did 10 to the third, you had 3. So if you do 100 to the third, you're going to have how many zeros? 6, right? Yeah. Okay, so then let's go ahead and see how we did. So you have 1,500 plus the 300. I have 0.2 times 10,000. So if 100 we move 2 places, 10,000 we're going to move how many places? 4, right? So 1, 2, 3, 4. So that would be what number? 200. Okay, I have 6 zeros, so I'm going to take 0.0001 and move how many zeros? 1, 2, 3, 4, 5, 6. So I'm going to put my placeholders there. Okay, so I have 1,500 plus 300 plus 200 plus 100. Okay, so 1,500 plus 300 plus 200 plus 100, which will give me my final score of what? Good. And it is money, so I am going to put the 0.00. Okay, and then for your second part, it says, what are your answers, and it should say in, not is, in part A represent. Okay, so I want you to think about that for a second. Okay, so what does C of 10 represent? Does anybody feel like they got it? Yeah.
The cost of producing 10 yards of the fabric and 100 yards of
Yeah, perfect. So C of 10 represents the cost. Which is $1,532.10 for producing 10 yards of fabric. And C of 100 represents the cost. 2,100 for producing 100 yards of fabric. Okay, this is something that you'll have to do on your chapter 2 test as well, so don't skip over that just because you don't like writing. Okay, it is something that you'll have on your test. And then the last one says find C of 0. What does this represent? So if we're finding C of 0, if I plug 0 into my original equation, the only thing I'm going to be left with is the constant term. What's my constant term? Yeah, the 1,500. Do you guys know what that is going to represent?
Startup cost.
Okay, yeah, so it's not just the cost of manufacturing 0 yards, but that has to include your startup costs, your production costs, right? Maybe you have to rent the equipment or rent a space where you're going to be making the product. So the C of 0 represents all of that. section 2.1, 27 through 31, 34 through 36. Okay, and I already do have your guide up as well. Okay, when you're doing your homework, if you're feeling pretty good, then I would do like a section at a time and then check. If you're unsure, I would try the problem and then check it. That way you don't have to go through practicing the wrong way every single time. Okay, so you should be using that to help guide you. And then you're able to check at the same time. That way you don't have extra to do on your homework log.